Number 20 says a sample of solid potassium chlorate was heated in a test tube and decomposed by the following reaction. The oxygen produced was collected by displacement of water at 22 degrees Celsius at a total pressure of 754 torr. The volume of the gas collected was 0.65 liters, and the vapor pressure of the water at 22 degrees Celsius is 21 torr. Calculate the partial pressure of oxygen in the gas collected and the mass of potassium chlorate in the sample that was decomposed. Okay, a lot of information. Look at the diagram here so we can have like a little bit of a picture of what's happening. So we have our potassium chlorate decomposing. That's why we have a Bunsen burner. The Bunsen burner will decompose it, and it forms oxygen gas and solid potassium chloride. So our solid potassium chloride is not really in the picture. It's probably somewhere in this mixture. But the oxygen gas will actually leave the mixture and can be collected in this airtight chamber. But notice it's airtight because it goes through water. So we're going to have to account, just like we did in the gas laws lab, we're going to have to account for the water vapor pressure that is also present in this container. So there's not only oxygen molecules, there's also water molecules from the water that we actually have. Okay, so this question asks for two different things. The first thing it asks for is to calculate the partial pressure of oxygen. Okay, so we want to know how much of this is just oxygen. How much pressure of oxygen do we have in that container? And the second thing is the mass of the potassium chlorate that actually decomposed. So let's start with our partial pressure of oxygen. We know that the total pressure equals the partial pressure of oxygen plus the partial pressure of the water, because only oxygen and water are in that container. We also know that our total pressure is 754 torr, and the vapor pressure of water at 22 degrees Celsius is 21 torr. So our P total is 754 torr, and our P of oxygen is what we want to figure out. We want to find that pressure of oxygen, and our pressure of water is 21 torr. So this is simple subtraction, and we should end up with 733 torr. So 733 torr equals the pressure of our oxygen. So that is our first question. We finished that. So we just need to remember 733 torr equals pressure of the oxygen. Our next part is to determine the mass of potassium chlorate that was decomposed. We weren't given information about potassium chlorate specifically, but we are given a lot of information about oxygen. So if we can determine the moles of oxygen that are produced, we can convert from moles of oxygen into moles of potassium chlorate and then figure out the mass of potassium chlorate. So let's see if we can do that. We are told that we have 22 degrees Celsius. The volume of the gas is 0.65 liters. So if we're going to use our ideal gas law to calculate moles, so PV equals nRT, we can divide both sides by RT, and we get N equals PV over RT. Our pressure, remember, we are looking for moles of oxygen. This is just moles of oxygen. So our pressure will be our pressure of oxygen. The volume is the volume of the gas because the oxygen is taking up this volume. Our R is a constant, and the temperature will need to convert 22 degrees Celsius into Kelvin, so we will add 273, and our temperature will be 295 Kelvin. So now we can figure out our moles of oxygen. So go ahead and take a minute to find your moles of oxygen. So hopefully when you plugged in all of the numbers, you got 0.0259 moles of oxygen. Make sure to convert from torr to ATM for your pressure because we have ATM in our ideal gas law constant. So we now have our moles of oxygen, but we want the mass of potassium chlorate. So take a minute and try and convert from moles of oxygen into mass of potassium chlorate. So we go from moles of oxygen on the bottom, moles of potassium chlorate on top. And then we are going to convert from moles of potassium chlorate, and I apologize, the rest of it is didn't make it on the slide, to moles of, to grams of potassium chlorate. And so to get these numbers, the mole ratio is 3 to 2. 3 moles of oxygen gives us 2 moles of potassium chlorate. And for our grams to moles, we are just looking at the molar mass, which is 122.46 grams of potassium chlorate in every 1 mole of potassium chlorate. So plug that into your calculator, and you should get about 2.1. There should be 3 significant figures, so I apologize. In my calculation, I just did 2. So you should get about 2.1 grams of potassium chlorate. And that is the end of that problem.